Thank you very much, Marta, and also thank you very much, Ariadna, for introducing us and also giving us the chance here to present BSF services. And I want to thank you, everyone who is participating today, taking the time. Appreciate that for listening into BSF services. My name is Marius Hefele. I am the product manager for services located in Heidelberg, Germany. And I'm going to be one out of two people who are going to present the webinar today. The other colleague is my colleague Florian Fischer, who's heading the Services and Solutions Department, who's also the key account and project manager for Xenius. This is this is the case study that we want to talk about today. Now, what can you expect of this webinar today? We want to really present you how you can get the full potential of 3D printing materials. And we do this by giving you an introduction into football helmets. We're going to explain the evolution of NFL helmets and the NFL Helmet Challenge to really explain why it is important to continue to develop and innovate protective gear such as helmets. In the second step, then, we're going to explain how we do that. So how is it that we develop this football helmet? We do this with a case study together with Xenius, and this is going to be broken down into two phases. First phase is more on the technical side. This is going to be presented by Florian. So it's the ideation phase, the design, the FEA simulation, and then we're going to break it down into the second phase, which is covering the cost analysis and sustainability. Everyone knows football. I think maybe you have not played it before, but you've probably at least already seen it, maybe in the Super Bowl or any kind of major events, maybe on TV. It's a great sport. It's a very intense sport. You have two teams, 11 players going against each other, carrying the football from one side to another. By this, they typically try to, score a touchdown in the end zone field. By doing so, they typically tackle each other, they hit each other. And with the tackling and with the hitting, injuries occur. So in order to protect them against injuries, they typically wear protective gears. So you've seen it, they typically wear, these shoulder pads, they have these gloves on, and they're also wearing a helmet. The helmet is supposed to protect them against any kind of injury, against, brain damages or the skull. Now, but it turns out actually that there was a time when football players did not wear any kind of protection. And also today, if you look at the protective gear, it does not fully guarantee safety for football players. So if we go back all the way to the 1890s, this was a time when football players actually did not wear any kind of football gear. So they didn't wear any shoulder pads, they didn't wear any football helmets, no gloves, no nothing. But then in 1893, there was Joseph Mason Reeves, who was playing back then for the United States Naval Academy and suffered a major injury. So during a tackle, he was injured, and he was given two choices by his doctors. They gave him a choice to either quit the game or to face severe injuries or even death. And Joseph Mason Reeves, he was young, he liked the sport, it was his favorite sport. He really loved playing it, and he didn't want to give up. He didn't want to quit, he didn't want to cancel it. So what did he do? He went to his local shoemaker to ask him to create a mushroom-shaped, soft leather padded cap that would protect his skull and his brain against injuries. And the shoemaker created this helmet, and he wore it for the rest of the season. Now, this is how the football helmet was actually created. This is how it was developed. But even in the early 20th century, protective gear was not necessary. It was not optional. It was not mandatory. It was optional. And actually, a lot of players decided not to wear it. They decided against it. Why? because the material made their helmet too sweaty, or the head too sweaty. It was too hot underneath, so they felt like this wasn't really helping them. So they decided against the protective gear. And of course, with not wearing any kind of helmets, not wearing any protective gear, more and more injuries occurred. And with more and more injuries, also the innovation of the helmets continued to grow. And this is when, now here on the left side, in the 1950s, you see what the typical helmet looked like. You have here a hard plastic helmet that covers the brain against major impacts. But even in the 1950s, they actually did not have this bar that you see here in the front that typically covers the mouth. But in 1955, you had the quarterback Otto Graham was playing for the Cleveland Browns, and he was hit during the game very, very severely in the face, and he had to be stitched back together. So they decided, okay, it's a good idea to actually protect the face with this bar, and they added this bar to the helmet. And in the 1970s, after more and more injuries, they decided, okay, we actually have to not only protect the face, the mouth region, but also the eyes and the nose. So they added additional bars that you see here in the center. So in the center here, you have this hard plastic helmet that looks somewhat common to what a normal football helmet looks today. You have a polycarbonate outer material on the outside. You have a foam-like pattern in the inside, and this was supposed to be protecting against injuries. But after a while, after some time, they realized that still many injuries occurred, and they continued to innovate this design. At some point, they added some kind of radio transmitters for better communication between the players and the coach, and it became more and more modernized. And then there was a big survey in the beginning of the 2000s. And in this survey, it actually revealed that there is still high risk of head injuries among the NFL players. And this prompted the three largest football helmet manufacturers, Schutt, Riddle, and Zenith, to design completely new and improved helmets specifically aimed at player safety. But despite these safer models, there are still many cases of many players with concussions. There are 40% of retired NFL players who suffer from headaches, from all these long-term damages that they got during the time they played. And these are young people like Jason Reeves who love to play the sport, who have a passion for the sport, and they don't want to give up, they don't want to quit, they want to continue to play that sport. So so safety remains a top priority for NFL, and they want to ensure that this can continue to be played. And so the NFL actually spends more than $60 million to invest into improving the football equipment like helmets. And one way they do it is by funding the NFL Helmet Challenge. Now, the NFL Helmet Challenge aims to accelerate the development of safer models of protective gear by bringing together experts, innovators, and helmet manufacturers. And the idea and the goal is that models are going to be developed that actually outperform the already existing best performing helmets out there by a double-digit number. The NFL Helmet Challenge is awards the winner with over €1 million or $1 million. And this is where we come into play. Zenith partnered up together with BSF, Forward AM, and together with Rion, as well as the University of Waterloo, to sign up for this challenge to develop a new, safer model of a helmet and develop the next generation of helmets. And we put our heads together. Everyone brought in their expertise, and we successfully developed the next generation of a football helmet. Right now, within this challenge, we are among the first 3 winners granted more than $500,000, and this is the story of how we did it.
So, and from here I take over, and a big welcome also from my side. And yeah, as Marius already said, this all started around 2019, so almost 3 years ago. And when Xenet approached us and said, okay, look, we want to participate in the NFL Helmet Challenge, and we do want to use 3D printing in this challenge because we believe with the freedom of design we have here and the materials which are coming, this could be the future, especially to improve protective gear, not only in the helmet, but everywhere. And really the performance and the weight has to be improved. And it all started with the ideation phase. We were sitting together discussing what we can do, how we can do it. And we wrote an application to the NFL Helmet Challenge and have been then accepted, granted some money to really start in the first phase, making a first prototype with the goal to, which the NFL set for all of the participants, to improve kind of the overall score which they have in the NFL to kind of rate the performance of a helmet. And in this kind of projects, we normally start, and as well in this time, with an ideation phase. So we were sitting together, and you see one of the first drawings here to find out what we can do and how we can start. And in the next phase, then we went to the lattice design, used simulation and our material modeling. And I will show in the next slides how this all kind of came together and also brought us with all the services we have today. I think this was really one of the pioneer projects which brought us to where we are now compared to 3 years ago. And on the next slide, you see a little bit on how we started. It was really drawing, writing. There were several workshops where we sit together, looked at the helmet. We tried to really understand how is the helmet working today? What is the drawback? Where can we improve using 3D printing, really the performance, and where can we still keep the old proven materials and way to manufacture? And it became really fast clear that for sure the foam has to be replaced. We also took a look at the shell, and even our first model we introduced to the NFL had a 3D printed shell as well. But the main focus was on replacing the foam and seeing if we can reduce weight, reduce the number of parts, and also improve the impact and performance, especially on, let's say, not a straight impact, but also rotational forces which happen if you don't have a direct crash, but more shear forces when you have a side crash. And with this idea, we went forward, started to look in what kind of lattices could we use, what kind of unit cells can we use to have optimum performance. And I think this is something a lot of people got aware over the last 3 years, but 3 years ago, this was really one of the first studies. And what you see in the background here, all the gray lines on the left graph, are all kind of lattice cells we tested at this time, all out of our Ultrasim TPU. And all with the same weight. So they all had the same density and weight, all kind of different cells. And you already see a huge difference in the performance when you look over force and displacement. And I just highlighted a few to give you an idea that we really had to look, what is the perfect lattice cell for this application? And normally, let's say we start from the bottom. This is kind of a framed X type, which has a really low linear stiffness. You can use it in a mattress or a pillow and so on. It gives a nice feeling, but comes quite fast directly fully back, like a rebound. Then the X type, which already shows a little bit of an, let's say, plateau in the middle, which means it always absorbs a lot of energy, but still quite low on the force level, meaning you could nicely use it still on a seating and so on and get kind of a cushioning effect. Then you have some lattice types like the Ventile here in green, which has a higher stiffness at the beginning, quite linear. And what is not drawn here, you also have a hysteresis, which is almost on the same line. This means you have a really high rebound. And we saw later use in this, especially in the footwear industry. And the one which we chose at the beginning here was this cubic-like cell. And you see already from the graph that it has a quite strong stiffness at the beginning. The force is really fast going high. It means it feels really hard when you push it, but then it has a really, let's say, long time where it stays at one force and is compressing, but is not increasing the force. And this normally means you have a high energy absorption. So the area below this curve is then the energy absorption you normally see. And we started with this lattice at the beginning and developed it a little bit further to improve the properties we see here. So the cell which was used in the end is not exactly this cubic cell, but it's still close, but it has a few improvements, especially to absorb side and shear forces, to have a late impact, to bend in the direct way as we want. And at the beginning, we were just engineering this, but it was fast clear that we have to test way faster, even with 3D printing, where you can have a quite high rate of testing, printing, testing, printing. So we started to look more and more into the simulation. And if you want to start with simulation, well, you first need a material model. And this was something we were working already on, especially for the flexible materials with our BASF colleagues, which have more than 20 years of simulation experience and normally support all the injection molded materials to our customers also with a material model so they can simulate those kind of injection materials. And we wanted to include this part of the BASF also into 3D printing. And so we started to run even more and more extensive tests, as you see it on the left, which is not just a tensile test, but can be biaxial test, high impact tests. Maybe Marius, you could play the video on the left bottom if you click on it. So these are really high impact tests, high strain weight, different kind of temperatures. We measure all kind of those data. And then those are transferred to our Ultrasim team and software, which is a software to generate material models out of this data. So we do fitting of this data, optimizing those data so that in the end, we have a material model which can be used in typical FEA solvers like an Abacus or an ANSYS solver, and implemented it then into the typical test NFL is giving and providing for simulation. And using those kind of data and models, you can really go one slide further, Marius. You can see here, the challenge was to get a high energy absorption. We wanted to have it tunable in force levels. So depending on where you need it on the helmet, the force which has to be taken in during an impact has to be different. Going from just the cushioning, what you feel, to a really impact absorption. And we wanted as late compaction as possible so that you have a huge deformation until the force is transferred to the head. And using simulation on the single lattice beams, later going to a full unit cell, even later going to really parts of the helmets, we optimized the lattice further and further to fulfill the NFL requirements, always taking into account that we need the lowest weight as possible in those kind of structures. And this was all implemented into the helmet and the first prototype. And with this, we then in 2021 sent in the first model and had to wait for quite some time to get feedback because it was quite interesting. The NFL took some time. They measured all the helmets which were sent in and so on. And in the end, they set the highest a score which was supposed to be passed for the winner, and none of the appliance did pass this really high score the NFL set us out as a gold. And therefore, the NFL decided to name 3 finalists, and Xenet was one of them, and provide all of those finalists with a new funding so they could go into the commercialization phase. And so Xenet did win almost $500,000 at this time. And especially proud we have been on the quote Xenet gave us, which you see here, like Ultrasim capabilities of forward IAM are second to none. It's a game changer to solving the very complex problems with virtual and an infinite number of possible solutions. And I think this kind of story we played several times with several of our customers, always when it is needed to really fast iterate, find a perfect solution for a certain, either a norm or an performance, always taking into account that you have a low weight. Yeah, I hope this gave you a little bit of an insight on how we can use our simulation capabilities to really speed up a project, bring it to the highest performance. And during this project, it took 3 years. We developed a lot of methods which are now more or less ready to use, really automized, so we can really go really fast from an input requirement to the final lattice, which is needed for a specific application, often in protective gear, but it can also be in footwear, bike seats, and so on. And yeah, with this, we finalized the first phase, and I hand back to Marius, who was really working or is working a lot on the second phase with Zenit.
Thank you very much. So yes, with the technical solution that we have just seen now, we start into the second phase that is more looking at the commercialization, meaning we have to understand the application from a cost perspective, but also from an environmental perspective. And the overall idea here in general was to better understand what are the costs of parts and do we meet the target costs. And you saw the helmet, the finalized helmet just now, and I put it here on the left side as well. The question was if you actually have a bulky helmet like you see here, and you put it into an HP machine and you have a limited space inside the build unit, and you're trying to nest it, no matter how you turn it, no matter how you rotate it, the maximum number of parts you can nest within one build job is 2. So we start with 2 helmets per job. And if you now look into the cost per part and you look into what's an overall print job of an HP machine costs, you quickly understand that you have a lot of material that is not used. You have a lot of printing time that is basically used only for 2 parts. So the overall costs are simply too high. It's too expensive in this current version. Now, we also understand what are the target costs, because those are typically given in such a project in the very beginning. So the customer has some kind of idea of where they want to go. And looking at where we're starting here with 2 helmets, we quickly understood that we have to actually do some more ideation phases to drive down the costs in order to meet the target at around 9 helmets per job and around 80%. So because this was too expensive, we started a new ideation phase that we call the segmentation. Segmentation means that we segmented the very bulky helmet into separate parts that you can see on the left side. You have all these different colors in green and orange and yellow. These basically represent the different segments. Now you have single segments that you can put into a build job, and you can nest them, and you can use much more of the overall build job. This drives down the machine costs, and you use more of the overall material, driving down the material cost per part. So you see with the new segmentation, we have, instead of 2 helmets per job, we now have 4 helmets per job. This essentially reduces the overall cost by 20%. Now, but looking at the target cost, we see that we're still too expensive, so we have to continue working on it. Now, because this is a project that is not going to be not going into serious production today or tomorrow, we also have to take into account the future market developments. So this means we have to look at what is the impact of these market developments on the cost per part within the next 3 years. And there are technical assumptions to take into account, and there are business assumptions to take into account. On the technical side, you will have somewhat of a higher refresh rate for the TPU01 that essentially reduces the material cost. You have more efficient printing modes that are able to, or that will be able to print faster, that don't take as much printing time, which means that you can drive down the machine costs of the overall parts. On the business side, of course, in future with higher production volumes, you will also have lower prices for material, as well as lower prices of hardware. And taking these assumptions into account, you have overall, together with the segmentation, a cost reduction of around 50%, which, again, looking at the target cost, is still too expensive. which means that we had to go into a second ideation phase. And this is what I call the armadillo solution. You have here on the left side an armadillo, and an armadillo is typically, when it's being, when it's getting into danger, when there is some kind of predator, it typically rounds up to a ball. It tucks in all its feet and the tail, and it really forms a ball with a hard shell outside. Once the predator is gone, it typically unfolds, and it continues to walk away and does what an armadillo does. And this armadillo actually very much, well, we associated the helmet very much with this armadillo, because the helmet in the case that we showed you just before is still very round. It's very bulky. It's cannot be optimized for nesting. So we use this armadillo solution to really optimize the nesting, and this way drive down the cost. And with this, we were actually able to get overall, instead of the very beginning, the two helmets in one build job, up to 9 helmets per job, and meet the target with driving down the cost by 80%. Now, going away from the cost perspective, we also want to look at the sustainability perspective. And from a sustainability point of view, it's very important to understand, when developing and producing a part like this, any kind of 3D printing application, we need to understand what is the CO2 emission that we will cause. And this is something that is very close to our hearts. This is something that we within BASF Forward continuously to drive forward, to really understand the full CO2 impact, but also the overall environmental impact of our materials and the parts on the environment. And it's a quite lengthy process, because in the very beginning, first of all, you have to measure. You have to measure to provide transparency and information. You have to understand what are the different inputs in order to produce a material, what is the machinery, what is the electricity, what are consumables, all the different raw materials. And you have to put this together to run life cycle analysis to understand what is the overall footprint. In the second step, you can then look at, now you understand where the carbon footprint is, and you can actually reduce it or deploy measurements in order to bring it down. And in the third step, it's the carbon compensation. So there will always be somewhat of leftover that can be though compensated by carbon compensation projects or carbon compensation activities in order to help here the environment. And this is something where we are going to next, also with Zenith as a next step. We have here a workflow of a typical life cycle assessment, really from cradle to grave. So you start in the very beginning with the material production, over the manufacturing process when the helmet is being printed. You look at all the different inputs that are going into this into printing such a part. So what is the material? What is, for instance, also support material for our filaments or for our resins? We have consumables, such as, for instance, here the agents. You have, of course, a lot of energy going in there. You have steel for the machinery. You have waste that is being produced. So you check really for all the inputs and the outputs. You look at the post-processing, meaning you have depowdering, blasting material. You have maybe some kind of vapor smoothing, solvent. You have a coating, and then you typically have a use phase. And in the end, the part has to be treated. So either it can be completely mechanically recycled, or it has to be incinerated, or in worst case, it's going to be landfilled. And this is something that is representing a very generic life cycle assessment. This is something that we do internally, and want to also do this more and more externally to provide this kind of service and more transparency about the carbon footprint and the overall environmental impact. So summing up, we started in the very beginning with why it is important to develop these protective gears. We presented that in the very beginning, actually all the way back in the 1890s, NFL players or football players did not use any kind of helmets, any kind of protective gear. We started with Jason Reeves in 1893, who first introduced the helmet by asking his shoemaker after a severe injury. And we went all the way to the 1950s with this hard plastic helmet, going to the complete evolution of the helmets. And we showed you with the different lattice designs where we developed a new lattice that really absorbs the energy that is laid out for the performance, together with guaranteeing also that the design works with the material data and model, and also with on the commercial side with the cost analysis, and in future also with the sustainability analysis, developing the next generation of footwear helmets. And with this, I want to first close the webinar, and thank you very much for your attention. And we are very much open to any kind of questions you have. And yeah, please let us know. Thank you.
Okay, thank you, Marius. Thank you, Florian, for the session. Now let's open for the Q&A. So, any question through the Q&A chat box, as you recall, and raise your hand, and we can allow your mics and do any question live. Let's do it a bit interactive. You can stop sharing, Marius. And now let's see. Okay. Okay. We have the first brave one. Rafi, you can unmute yourself.
Hello, can you hear me?
Hello. Yes.
Great. Good morning. Look, I would wonder. So it's for me it's a great case or story. I love it in different ways because you're explaining it great. And on one hand, on the other hand, my son is a football player, so I was in front of the shelf, choosing either a Riddle normally manufactured or 3D manufactured. So my question, of course, goes into which kind of helmets or which kind of BSF material / MGF production is already on the shelves. I think nothing yet. So how old is the story, or how fresh is it, and what's the next steps? Can we imagine that it's going to be, as you mentioned as well, commercialized or not?
Yeah, so the story is old. We started 2019. We are now in the second phase of commercialization. And I think you can expect to have a helmet in the future out of our material in TPU01. Of course, this is up to Xene to do this, but we are quite confident to go there. On the other side, it will take quite some time. So we started with this NFL Helmet Challenge, more in the research phase. Now we're going to commercialization, and then it goes into in-field testing. So by now, all tests have been done in the lab, but one of the next steps will be on-field testing, either with specific players, with a few test players, then for a single team or two teams, and then hopefully it can start as a high-end product at the beginning and then trickle down to maybe the more general league. I think a development in this kind always is risky, takes a lot of time because you have to be sure it is working. You don't want to endanger any player. But we're quite confident that we go into the commercialization in the future.
That's great. So how would you then differentiate the Riddle 3D helmet to the one you have or you made out of the TPU?
I can't do a one-on-one comparison because I never had a Riddle helmet on hand, but I think from the scoring, the NFL scoring, we will outperform it in the end. And I think the goal here is really clear to also have a commercial valid product which can go into larger scale production. So we really try to drive down the costs at the moment. That's one of the goals. And
what is the benchmark? Has this been the benchmark, the actual helmet of Riddle, the 3D printed one, or was the benchmark independently of the actual developments?
It was not in the benchmark. Yeah. No, It was not in the benchmark. No.
Okay. Okay. Thanks.
Thank you, Florian, and thank you, Rafi, for the question. So I'm going to launch a very quick survey just to gather your feedback. And then we have 2 more questions on the Q&A chat box. Marius, Florian, I don't know which one you want to address first.
Let us read, or can you read out one? We address them all if there are not too many.
Okay. So we have a question from Frank. He said, could you expand on the armadillo technique used to optimize build chamber usage?
Unfortunately, we can't. I cannot go into details. This was agreed with Xenet, that we for now not share the details on how we did this. I think the armadillo gives you a bit of an idea what we did. So in the end, we had to compress not the lattice itself, but the parts themselves, doing this a bit more than just on the segmentation. Sorry that I cannot share more details here, but we really hope that we in the future can offer this to more customer, this kind of technique.
Frank, if you need any more detail, just let us know. We can allow your mic. We have another question from Jacobo. Florian, Marius, I don't know who's gonna answer that one.
Yeah.
He said, when you target the NFL, you have to target the whole league, or can you talk to the teams directly during the product development?
Not 100% sure if I understand the question correctly, but I think, so Xenet is talking, they have several players. I'm not sure if they have full teams, but at least several players they work with. So they talk directly to them. We ourselves do not talk directly to them. And we do, I mean, with the 3D printing, you normally target first, or that's, I think, the goal, the high-end league, and then go down to maybe the college league and so on. But really, this is commercial stuff, which normally Xenet has to decide and do. And also on the testing and feedback, Xenet is really on the lead here and has the most experience.
Okay, thank you. Another question from Rafi. With whom from R&D within HP did you work together, or is this that case was developed only by BSF?
This was really developed between Xenet and BSF, so HP was not directly involved. We, of course, have once in a while feedback loops with your HP teams on especially looking what can we expect in 3 years on the print mode, where can we optimize for lattice printing. There, HP was always involved, but not directly in the project.
Okay, thank you. Let's see if we have more questions. Remember that you can also raise your hand and make any question live. As usual, we will share the content, the slides together with a replay to all the people that we have invited. Another question from Jonathan. What lattice software did you use?
Yes, it's a mixture of different kind of softwares we are using. The design itself was at the beginning done in Rhino Grasshopper, later on more and more with Anthropology, but it then always loops into the different simulation software and optimization FEA tools. But I would say at the moment, the main tool is Anthropology.
Okay, thank you. Next question. What other services do you offer?
So we saw the different services that we offer within the lattice design development, also within the material modeling and the cost analysis, as well as the sustainability. And typically we offer services for all stages of customers, because typically we have customers that are very new, that are beginners, that are not very much experienced with 3D printing, or let's say with lattices or with simulation. And for these, we typically offer a starter solution. So it's a starter solution to really get a quick entry into the services. For instance, for the lattice design, the starter solution would be what we call the lattice catalog. So we have a full catalog of different applications that you can choose from. You send us the STL, and we generate a lattice inside of there. And then we have really premium solutions that target more customers that are a little bit more experienced, that want to go in depth, and then also enterprise solutions, which really targets customers that want to have a deep dive that where we sit together to really understand the overall problem, similar to what we did now with Xenis, to have this this support along the complete project to develop a helmet together.
Marius, we have Rafi again. Rafi, you can unmute yourself. Make any questions.
Yeah, just quickly, out of interest, we have a German event at BSF on the 11th and 12th. Are you both there? Maybe, because that would be a great story as well to tell the prospects which are coming. There will be a couple of companies. So first, and second, with all that knowledge, or with this knowledge, you know, I don't know whether that was a key project where you know, digged into all these details and gathered all these, let's say, kind of expertise, if you want so, or have you worked in parallel with different ones, or different cases, different, I don't know, investments, and what are you doing now with this knowledge? Do you have a sales force to spread that on the market? How do you PR that?
I can maybe answer the first question. Florian, you can take the second one. So you the first question, I think, was regarding the 11th and the 12th of the event. Is this? I'm not fully aware of an event, but I will be at least on the 10th of October in Barcelona on the IM3D Summit. So we're going to have there on the 10th of October in the morning the summit of IM3D, where I think HP is going to play a big role. So definitely going to be there. And in the evening, we're actually going to have the Forward M Innovation Award final, where also HP, as well as other sponsors, are going to be participating. So I'm going to be for this one there, but not for the 11th or 12th, as I'm not aware of it yet.
Yeah. But maybe send us an email afterwards and we can check if we can be there. We are always happy to present it. And yeah, that's about the second question. We try to spread this more and more. It's always difficult when you develop something with a company together that you are not allowed to spread the details. But especially in protective gear, we try to do more and more. And you can see also on our webpage, there's one use case, which is on the protective pad of the back for motorcyclists. I think we just had some requests also from HP coming to support on an ice hockey helmet. We do work with somebody on bike helmets. So we do now use this kind of knowledge in the different kind of protective gear areas. And we also try to work on a kind of lattice catalog or library where we can offer more specific lattices directly, knowing that they are validated for a specific norm or specific application. So this is, we try to bring it into the market more and more, yes.
Yeah. Are you cooperating with Oechsler or not at all?
With who again?
Oechsler.
Oechsler, yes, we do. I think several occasions we do work with them on the lattice design for the TPO1, yes. But they often do a lot of design. They're also really capable on doing those designs. And then we often cooperate on the coding, as well as if they need simulations, we do try to support. But we are most of the time somehow involved in their projects.
Thanks.
And here's what we mentioned before. You have these different. We offer these different services for beginners. So these starter kits, basically the lattice catalog to choose application to design the right lattice out of our experience for customers. We have the lattice test pad that we're launching soon, where you get the physical lattice test pad. It's a 4x4 matrix that has different lattice parameters, different beam sizes, unit cells, etc., to meet the right shore hardness. And then we have, here applications such as the motorcycle seat that is basically a foam replacement offer for premium customers, as well as the enterprise with Xenis.
Thank you, Mario. So we had a question from Gabriele. Do you foresee opportunities to extend to other kind of helmets like cycling, skiing, motorsport, climbing? Any other opportunities?
Yeah, for sure, we do see it. especially, but maybe we have to differentiate between the different helmets. So they are the ones multiple impact helmets, I would call them, like football, ice hockey, where you can kind of, or you need the flexible material because you have to withstand multiple impacts over a game, over a season, and so on. And then we sometimes work on like a cycle helmet or a not diving helmet, like when you jump out of an airplane helmet. This is normally, you have to have higher performance, but it's also a single impact. So it is allowed to crash in the end. You just have to absorb the energy once, and you will always replace it after you had an incident with it. And there we then often work with some other materials, but also there we hope that, so we are coming with a stiffer TPU, but also PA11, we can work on those kind of helmets. But especially for multi-impact helmets, the TPU works really nice, ice hockey, football, and so on.
Good. A lot of questions. That's a very good sign. A lot
Yes,
of
I'm really glad.
interest.
Like sometimes you have this
And
quiet after webinar,
yeah,
but it really shows that you guys are interested. Thanks a lot.
and the content is great, by the way. So thanks a lot for putting together this webinar and transferring that knowledge. And let's see, we have more questions. And if not, we will liberate all of the attendees 15 minutes from their agenda, so which is very nice. And again, we will share, as usual, we will share the content and the slides together with a replay to all of the ones that we have invited. With this, is there anything else that you want to add, or?
Yeah, maybe just feel free to reach out also afterwards to me or Marius if you have any kind of additional questions which come overnight, or if you have customers you could think of those kind of applications or work we could do. We are happy to support, especially with HP. We have a lot of connections, but HP is huge, and we also sometimes get lost, but feel free to contact us at any time.
I will share your contact details, your emails, okay? Once sharing the content. Mm-hmm. We have last question from Jonathan. Have you guys looked into vibration dampening? Well, I don't know. Sorry, I don't know what is this.
Actually, yes, we just got a few times this request over the last months. I think we are not there yet on a full simulation way, but we did look at it, and it seems to come up more and more frequently over the last, let's say, months, especially for cycling, if this is helping to your question.
Thank you, Florian. Okay, so thanks again. Thanks all of the ones connected. We have a lot of people on that call. Thanks all our channel partners from EMEA and from APJ. And we'll share this content tomorrow. So they will have, if they have any question right after, they will contact directly to you. Okay, Florian and Marius.
Okay. Thanks, everybody.
Thank you very much.
Thank you, guys. Have a good day. Bye.
Bye-bye.
Thank you. Have a good day. Bye-bye.